All right, so guys, the last thing that we're going to talk about this chapter, in chapter 3, it somewhat relates to lines. They're not technically lines, but they are combinations of lines. It's the absolute value function. So we're in the linear function chapter, but now we're going to go into absolute values. And I know we've touched on these already a little bit, so we'll be a little bit quicker today, but here we go. Let's get straight into it. 3.8, absolute value. So remember that an absolute value, guys, is simply a distance from something. Typically, we're talking about a distance from 0. So even if I'm at -4, so just to make sure we're all back on the same page, if we're talking about a difference from 0, okay, we have, if I said, if you were at point 0 in space, which, you know, it could be wherever you're standing right now, and I said you can go 4 steps from where you currently are, you have a ton of different options, right? You can go in any direction 4 steps. But if we think about things as just in 2 directions, okay, which is what we do in algebra on an xy coordinate plane, then you could either go right 4 or you could go left 4, but the distance that you travel is 4 no matter which direction that you go. Okay, that's an important thing to remember with absolute values. So if I'm sitting here on -4 or +4, my distance to 0 is still 4, no matter how I look at it. Okay, so the absolute value of -4 equals 4. The absolute value of 4 also equals 4. Absolute value, whenever you see that in your brain, you should just replace that with distance, right? It is a distance. And distances are always positive. All right, so how do we find the vertex on an absolute value function? Because we know from a previous lesson that an absolute value function will always graph in this V shape. And again, the reason for that is what we just went over. So there's always this place where there's a symmetry line, or where something happens, right? So that becomes more important in the chapters to come when we get into quadratics. But for this one, we want to know where this smallest point is, called the vertex, where these 2 lines come together. So whatever makes the absolute value part of the function go to 0 is where this vertex is going to lie. For instance, if I have the absolute value of x minus 3, then since 3, if I plug a positive 3 in here, makes this go to 0, this thing is going to shift 3 spaces, and since it's positive, it'll be 3 spaces to the right. So the vertex will be there, and it'll look something like this. All right, so again, what you're doing to figure that out, and if I didn't make this clear, you're setting what's in the absolute value bars to equal 0 and you're solving. So if you want to see that algebraically, I should show that to you as well. This would be x is equal to 3. So how do we graph these? What I would do is I would include, I would make a table, and in the table I would include things that are both to the right and to the left of the 0, or of where the vertex is. So here, look at that, I have x minus 4. So what I need to do is, I need to determine where does this thing have a minimum. To do that, I'm going to set it to equal 0, okay? And when I set it to equal 0, I see that x is equal to 4. So that's going to be the place where I have a minimum. Now I want you to be careful here, because if you add or subtract something on the outside of this, which we're going to do soon, then from that minimum place, you are going to have to move the whole thing up 2 or down, depending on what it says. But for now, if it's just an absolute value, it's just going to be shifting left and right if it's happening on the inside. Okay, so for this, we're going to start with 4. Put it in the middle of your chart. Okay, if you plug a 4 in, you get 0. Then we want to plug a 3 in. If you plug a 3 into this thing, you get the absolute value of -1, which is 1. Okay, and then I would plug a 5 in to see if that's the same thing happening on the other side. Make sure I got my 0 correct. So if I plug a 5 in, sure enough, I get 1. Okay, then you plug another number in. Let's plug a 2 in. You plug a 2 in, you get 2. Okay, you plug a 6 in, you also get 2. And we end up with this V shape. So absolute values are always going to have this V shape whenever you see that. All right, let's go to example 1. It says graph. So here's where it goes a little bit different. I'm not sure why this format's so weird, but this is going to be the absolute value of x, then minus 1 on the outside of the function. All right, so let's see what that looks like. Whatever makes the inside go to 0 is where this thing is going to have a minimum value. So it's going to happen at 0, right? So let's plug a 0 in. If I plug a 0 in, 0, absolute value of 0 is 0. 0 minus 1 is negative 1. So at 0, we're at negative 1. So notice, that's going to be my minimum. It happens at 0 on the x, but now I'm down negative 1 because we're subtracting 1 outside the function. Okay, so let's move to the right and to the left of that. If I plug a 2 in, you could have plugged a 1 in, but this graph's going by 2s, so I chose 2s. If I plug a 2 in, absolute value of 2 minus 1 is just 2 minus 1, which equals 1. So at 2, I am at 1. And then if you plug a negative 2 in, you get the same exact thing. You get 1, because the absolute value of negative 2 is 2. 2 minus 1, 1. All right, then we plug a 4 in, just to see what happens as we continue up. If you plug a 4 in, you get 3. Plug a negative 4 in, you also get 3. So at 4, we're at 3. Negative 4, we're at 3. So here's the shape of our absolute value V. And we're done with example 1. Example 2, oh, and do they want us to state the domain and range there? I don't think they do, but example 2, they're going to want us to state the domain and the range, so we'll talk about that. Okay, so we have x plus 2 in absolute value bars. We're going to set x plus 2 to equal 0 to find out where our minimum happens. Nothing happens on the outside of that, so it's going to be the smallest point. Okay, so I subtract 2 from both sides. I get x is equal to negative 2. So negative 2, this is not a good graph for this one. I apologize if that's the graph I gave you on your notes. So start there. Okay, so at negative 2, I'm at 0. Put it in the middle of your chart. All right, the explanation's there. Now let's go to the right of that. So if we go to the right of that, let's go negative 1. You plug a negative 1 in, you get absolute value of negative 1 plus 2. Absolute value of negative 1 plus 2. Negative 1 plus 2 is 1. Absolute value of 1 is 1. So at negative 1, we're at 1. Plug a 0 in to keep going that direction, and we would get absolute value of 0 plus 2, which is 2. Okay, so at 0, we're at 2. Now let's go on the other side of this. Let's go to negative 3. Okay, we're going to the other side of where that minimum happens. And if you plug a negative 3 in, you get 1. Plug a negative 4 in, you get 2. Okay, so we get this type of shape happening. Sorry again for this graph, that's not the correct graph. Need to fix that. Okay, and then they want us to state the domain and the range. So the domain is the possible x values on the graph. Okay, so think about this, guys. This graph goes off to infinity, this direction, and to infinity, this direction. So in the x, right, in the right and the left directions, I can plug in whatever number I want to this thing. I can plug in a billion if I want, or a negative billion if I want. So my domain, the possible x values, is just going to be all reals. I can plug in whatever I want. The range, however, is the possible y values. All right, and if no matter what you plug into this function, no matter what, this thing will never go below this axis in this particular case. Right? So the range, it includes 0 because we have a point at 0, but it's the y values where y is greater than or equal to 0. Okay, it's all in the y direction. It's only the numbers bigger than 0. We don't go into the negatives. Okay, let's look at example 3, which is 1/2 x. So the absolute value of 1/2 x, what makes that go to 0 is just 0. So this thing is going to start at 0. Okay, so if you plug a 0 into that, you get a 0 out, because 1/2 times 0 is just 0. Take the absolute value of 0, you get 0. Okay, then what I might do is, looking at my graph here, I might plug in 2 instead of 1, but you can plug in a 1, it's okay, but I'm going to plug in a 2. If you plug in a 2, 1/2 times 2 is just 1. Absolute value of 1 is 1. So at 2, I'm at 1. All right, there's my explanation. If I plug in a 4, 1/2 of 4 is 2. Okay, so at 4, I'll be at 2. And then I'll go in the negative direction. So if I plug a negative 2 in, I'll be at positive 1, right? Because negative 2 times 1/2 is negative 1, but the absolute value of negative 1 is equal to 1. All right, and then at negative 4, I'll be at positive 2 with the same reasoning. So here is my V shape for that guy. And the domain for this thing, all reals. You'll notice that's a pattern. The x's in this direction go off to infinity. Plug whatever you want in. But the range will never go below the axis again. So range, y values where y is greater than or equal to 0. All right, example 4. Now, supposedly this function models a dolphin's elevation in feet compared to sea level after x seconds, which is interesting. I find it interesting that a lot of these word problems, I've researched them, and a lot of the word problems that they put in here, even though they sound ridiculous, are actually true. So I'm not positive on this one because I haven't looked this one up, but let's take a look at this. So if this is the model for the dolphin, and we're talking about the x value would be in seconds, they want us to graph this thing. We're going to do it the exact same way that we've been doing it. Okay, so x, y table, whatever makes what's in absolute value bars, which is x minus 8, right? Whatever makes that go to 0 is where the minimum happens. So x minus 8 equals 0, we get x is equal to 8. So at 8 here, we have a minimum. Okay, so let's see what happens when I plug that 8 in. And so I'm going to start with 8. Okay, if I plug that into this thing, then what I get is 3 times the absolute value of 8 minus 8, which is just 0. So this whole thing goes to 0, minus 24. Okay, so at 8, I'm at negative 24. All right, let's keep cruising. So I'm going to erase that so we have some space. Let's go to the left of that. So I'm looking here, and I see that my graph goes by 4, so I'm going to plug a 4 in. If I plug a 4 into this thing, I get 3 times the absolute value of 4 minus 8 minus 24. Okay, the absolute value of 4 minus 8 is the absolute value of negative 4. The absolute value of negative 4 is positive 4. So we have 3 times 4. Notice I no longer have the absolute value bars because I took them out and turned this positive. Minus 24. That's 12 minus 24, which is equal to negative 12. So at 4, I'm at negative 12. Okay. What's interesting now is, what I want to look for is, I'm assuming if it's following the symmetry pattern that I should also get a 0, or sorry, not a 0, but a point right here. So if I plug a 12 in, I'm hoping I also get negative 12. So let's look at that. If we plug a 12 into this, right? So let's plug a 12 in. We get 3 times the absolute value of 12 minus 8, which is 3 times 4 minus 24. Same pattern, right? So we get a 12. And it's going to be a negative 12 because it's 12 minus 24. So that negative sign is very important. Okay, so when I plug a 12 in, I also get negative 12. So that confirms that. Okay, then let's look at one more point. Let's see what happens when we plug a 0 in. So if I plug a 0 into this thing, I get, let's change colors here. So I'm going to go to blue. When I plug a 0 in, I get 3 times 0 minus 8, absolute value, minus 24. Okay, that's 3 times the absolute value of negative 8, which would be positive 8. So 3 times 8 minus 24. 3 times 8 is 24, so this gives me 0. So at 0, 0, I have a point. And I'm not going to do the math for this, but you can see that another point here would be, since this distance here to the symmetry line is 8, I can go 8 in the other direction and have a point right there. All right, so there's my absolute value. And they don't ask me for domain and range on this, but if they did ask me for domain and range, this is a dolphin's elevation, so obviously it's restricted in some level, at some level. But if it wasn't about a dolphin's elevation and they're asking you for the domain and the range, the domain would be all reals, and the range on this would be the y values where y is greater than or equal to negative 24. It's everything above negative 24. But they don't ask us for that because we're talking about a dolphin, right? And so it would be kind of ridiculous to go off into infinity with dolphins. But anyway, that is how you would find it typically. The only other thing that I'm going to say, you guys, and the only before you go do your homework is this: if you have a negative sign out in front of an absolute value, something like this. We didn't do one like this, but you'll probably have one like this in your homework. What that does is it turns everything negative, right? So if you plugged a 1 in there, you would get a negative 1. You plug a 2 in there, you get a negative 2. You plug a 4 in there, you get a negative 4, etc. Plug a negative 3 in there, you're still going to get a negative 3. Okay, so notice how everything goes negative. So if you were to graph this, okay, at 1, negative 1, you'd have a point. By the way, at 0, 0, you'd have a point. At 2, negative 2, you'd have a point. And then at negative, we said at negative 3, you'd have a negative 3. You'll see that what you get is an upside down V. So a negative on the outside. It's very important, on the outside of the absolute value bar. We'll flip your whole graph upside down. All right, guys, that's it for today.